So guys, we're going to design a portal. The first node, then this is the node. I'll come to then this is the node. I'll come to select, then this I'll come to select, node cursor, pick node cursor, pick node cursor, under select node cursor, pick node, under select node cursor. Then now when I select node cursor, then now when I select it, I come to geometry. Click this place is translatory. Click this place is translational repeats. This is translational repeats. In the x direction, I want to have a span of 15 meters. Then I want to have a span of 14 meters. Then I want to have a span of 14 meters. I'll click OK. I have two of them. Now. I'll select both. Select both. Translational repeats in the y direction. Translational repeats in the y direction. I'll repeat 6 meters. Y direction. I want 6 meters. 6 meters. I'll link them. Good. Then I'll select this node. I'll translational repeats. I'll do the translational repeats. Going to the x direction repeats. Going to the x direction. Half of 14 is x direction. Half of 14 is 7. Good. I have that. Good. I have that. I'll select it. Translational. I'll select it. Translational repeat. Up the height. The height of this. This height. Very high from. This is very high from here. From here to here is 2 meters. 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 So it's 2 meters. So I'll put 2. So put 2. I'll put 2. Okay. I did this in the x direction. So I'll select translational repeats in my y direction. I'll put 2. Okay. Then here is add beam or pick beam. I'll add from here. Escape. I'll select. Come to select node. I don't need this node. I'll select and type delete key and delete it. So now, how many? So let's come here. Let's check. We have our polines. We have 1, 2, 3, 4, 5, 6. I want to put 6 polines on this structure. That's 6. That 6 is more like 1 meter. Yeah, but let's measure this beam and see how long we have. So we'll come to utilities. We want to measure, see the distance of the beam. Utilities. We'll come to beam 2, dimension, display. So we have 7.26. Is check calculator. Calculator. 7.26 divided by 6 are 1.2. Okay, so we'll be having 1.2. So now let's remove it. Remove. So select this beam, right click, insert nodes, enter numbers 6 times. Good. And we have now inserted our nodes. So I'll select the whole of this, come to geometry, so that I can duplicate translational repeat in the Z direction. Let's check. We have 1, 2, 3, 4, 5, 6, 7. So we'll go in the Z direction 6 times. 1, 2, 3, 4, 5. So we'll go in the Z direction 6 times. 6 times. Link. Open the base. Open the base. Oh, yeah, this 6 is the truss spacing, and then we are still going 6 times. Well, this one is the Porter spacing, the distance from here to here. All right. So now we step in that direction. Okay, so we have this. So we can now add braces to our structure. You can say add beam. I'll add the brace here. 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 So let's come to view. Well, I can turn this structure like this and do the same thing. Now I start here. Good. So let's take a look at the top. Let's click at the top. So at this top, how are we going to do? Like this won't work very well. We'll click a view like this. We'll click on this one of these view, and let us escape. Let us come back to select beam cursor, select all this, and let's go back to view. Good. You right click. When you right click on new view, display window. Good. Now we only have this, so we can be able to select, be able to come to geometry and add beams. So we start here. We'll go like this. no, or like this. You alternate it. I can, under view, we rotate this, hold this one, bring it, zoom it in and out, see your mouse, come back to geometry and pick your add beam tool. Good. So I can come to view, structure only, then the whole of your structure comes back. Yeah, so now we can group. The next thing we're going to do is we'll group these members. I want to group these members. How are we going to do that? We'll create groups. Yeah, when you come to utilities, you see groups. Where's the group name? Let's say column. There are beams. So you can select all these, control, view, associate. Good. I'll create another group, beam, tapered. These are the tapered. These are the ones that are tapered. So I'll use the top view, select this, control, select this, control, and 3D, I hold control, apart, associate, or we create another one, call this one polines. Also beam. Okay, go to the top, this one's let's select them, come to select, then on the beam parallel to Z axis. Good, all of them has been selected. Then I'll associate it. I'll create another one. What should I call this? Should I call this diagonals? Let me do that. Utilities group, create diagonals, beam, then immediately I click in the middle, they select control, come to view, turn this way, control, good, associate, I'll create another one, or maybe I'll call it roof diagonals, also beam. Okay, title blank, roof diagonals, no space in between, beam. Let's go to the top, bring this here, okay, come to select, beam cursor, tap in the middle, control, select this, control, select it again, select this, view, beam, okay. These are roof diagonals, associate, close. I think I'm done associating things. So once I'm done like this, I'm done with geometry. I'll come to properties. Under properties, come to section properties. Here now, I'll come to British, universal column. I'll choose this. See what under universal beam. Choose this. Okay. Then channel. I'll choose 150 by 75. I'll add. Then tube. Pipe 21 diameter, 3.2 thickness. Pipe will I choose? I don't know, let me just use angle for the diagonals. 75. Mm. 70. Close. So now let me select. To select now, select and assign. I'll use attribute by group. Select all columns. Then universal column. I'll select all columns here. So everything is selected. Assign to selected beams. I'll select tapad. Then unselect this one. I'll come to beam first. Tapad. I'll assign. I'll come to poline. I'll select this one. Poline. I'll assign to selected beams. I'll come to diagonals. I'll select this one. The diagonals of this one, say it is 75. Assign. Then then here, roof diagonals, so let them be 70. I didn't, some things are missing. No, nothing is missing. Let me rotate it. Let's see. Oh, I have this one. Oh, I selected everything. Assign. Oh, this has been assigned. Okay. So we're done with that. The next step is to come to material. We come to material now, select T, selected, now in view, select view, assign to view. Good, so that everything here is T. Specification. and then to specify, come to support, create support, pin, want to use pin, and view, come to view, but select node cursor, pick this first, select node cursor, assign to selected nodes. Good, that has been assigned. I'll come to view 3D. You can see that this has been assigned. So what do we do next? So we forgot something, specification. Under this specification, our polines, we want to release moment so that they don't transfer moment, they only transfer axial load to our portal frames. So we now come to beam here. Under release here, we make sure it's been released to MXYZ. We'll add that is from start, that's the start, and the end also MXYZ, beginning of the beam to the ending. Yes, so now select, come to select attributes, group, polines, good. So we'll assign to selected beams, good. We'll assign to selected beams. Let's start and finish. You can see, good. And we can close this. We are done with that. We're done with support. Then the next thing we're going to do is now we'll do our loadings. So for the loading, I want to make some reference in this textbook. I'll send it to you guys. Structural steel work, designed to limit state. Come to portal frames. We'll come to portal frames. You take your time and read some of these things. Well, we are going straight to the loadings. For the loadings, we'll get the sheeting insulation. This rafter poline, the software calculate the self weight, so we'll not worry about that. Then the imposed load, including snow. We don't have any snow in this part of the country, so also reduce for snow. So let's come back and come to loading. Load case detail, you add dead DL, I'll add live load, I'll add, then wind load plus positive, and wind load negative, add and close. So the next thing we're going to do is under definition, you see wind load definition, you add in this one here, there are some versions, still the same version, but there are some update versions. Immediately you come here you just see your ASC, then you just click on generate. But if it's like this, you choose we're using ASCE 210. We now add, we close, click on edit, we click on this one, and then we now add. Yes, when you come here, I will click on generate, wind speed 36. There's the basic wind speed we are going to use, meter per second. Okay, exposure, this leave like this, apply. Okay, they have been generated. Under exposure, you put 1, you add, you close. So for the exposure, I'll select everything, select exposure, select everything, and assign, use this, assign to view. I'm done with that. So I'll come back and close that. I'll come back to my dead load. I'll add to dead load. Okay, for dead load here, we first add self weight, add, then member load. For member load, let's pick our calculator. Let's add this, and sheeting 0. Sheeting is 0.1. Insulation 0.15 is 0.25. Okay, that's for the dead load, but the unit here is kilonewton per meter. What we calculated here is kilonewton per meter square. So that means we'll multiply it by our poline spacing. Now this is going to be rested on the polines, so I'm multiplying this by poline spacing, which is 1.2. So multiply times 1.2. Now our load is 0.3. Minus 0.3, add, close, come to live load, add, member load. For live load, excluding snow, we are going to use 0.5, 0.6 is 0.6 minus 0.6, add, close. Okay, then wind load, we'll add, we'll come to wind, okay, now coming. So wind definition is required in order to assign wind load. Okay, thought we did that. Let's check. Come here, add, generate 336 meter per second. Okay, we'll add first. I then add the first and then we'll close. Okay, so let's try it now. Wind, good. This is activated. Wind now. Wind in the X, no, look across. For this, the minimum, 6, highest 8. Let's add the factor remains 1 and close. Let's click on it and see. Good. You can see how it's acting this direction. Let's go back and show you. Okay, let's do this side, then I can show you. 4. Alright, click back on load. Now then click something else, click back on load. Load cases. Click this. Here. So now we'll add wind load. Come to wind load, then this time is minus coming in this direction. So start at 6 and 8. Starting, the wind will start there at 6 and at 8. Add, close. Select, you guys, if I select, you can see how it's affecting. Okay, that's good, that's good, that's good, that's good. So we have, so now let's so for self weight, we'll select it, assign to view, assign our self weight to view. Then under select attribute by group, select polylines, then click on live load, select live load, assign to selected beams. Yeah, it's there. As you can see, been assigned to selected beams. I'll come to dead load, same thing on polylines. The polyline now will transfer it to our tapered sections. Select, good. I have this. Okay, so I think after doing this, we'll now do load combination. Come to add load detail, add load cases detail, click on add automatic combination. I use automatic combination, PS, then generate loads, add, close. Okay, so now we can come to analysis, define, analysis, no print, close. Okay, if we want, we're going to analyze first. So let's first save what we have done. We haven't saved. Okay, we've saved. So let me see, save as from training analysis. Great, good. This is what I have. Then I can analyze this first before I can do the design. 0 error, 0 warning. So it sees that our design is okay. 0 error, 0 warning. We can go to, if you want to view output report, to that. Okay, also that. So now the next thing we're going to do is, if you want to come to post processing, okay, you can see all this. Let's click on utilization ratio. Okay, it's not showing yet. We're here to do our design, but let's see our reaction. You can see our reaction here. This is what we have. We can, what should we do? There's something I didn't do. I just remembered my load. Okay, good. But this my load. I didn't multiply for this imposed load. So I'm supposed to multiply it by, this is 0.6 times 1.2, 0.72. So let's go back and do that correction. We come back to analytical, come to loading, for dead load. I've done that for live load. The dead load now, edit 0.72 modifiers plus. Good. So let's do all the necessary things and then we'll analyze. Come to analysis. We've done this. We'll come to design. Under design, define parameters fy. We add track. You can see print deflection, expanded output report. Get a long list of reports. Can close under command. Tell it to check. Under command, tell the computer to check. Long group, select. Selection, optimize, close. So you can now be able to apply these things on this structure of select all py. So select py first, assign to view. I'll call it assign to view. Good. Track. Now you make sure that this code is BS code. Track 4. Assign to view. Track 2. Assign to view. Check code. Assign to view. Select. Assign to view. Okay. It's nice. So now that we're done with this, we can go ahead and run analysis. Yeah. Let's go to view output results. Okay, it's just a warning that members has been changed. The last analysis is actually nothing. So under this place, you can see our team members 275. These are the grade that we use. Modulus of elasticity, design strength. That is the design strength we use for our design. That's it. We have an extended result. I asked to print these bulky ones. You take time and go through all this. It shows the design members, the ones I choose and the one it was designed. Each member you see, data section, plastic, all these things. So now let's close here and come to post processing. Okay, good. So let's check our reaction. We want live load, but let's all loads. Dead and live loads always have the highest. Let's take for example, but if this is blocking us, want to select text, can move it somewhere. Okay. Okay, I always go with the highest. I'll choose the highest and design my foundation. Okay, well, these are the axial forces. Check your beam result and see. These are portal frame deflect. Well, when you take your time and go to this portal frame, you can see. This is it. A reaction. Good. And see just the same thing is done. So now, that is it. So let's come to the utilization ratio. Let's off our MZ. When you come to utilization ratio, you can see that there is no red. If it's red, then it has fade, but all are green, and none of the utilization ratio are up to 1. Good. So let's come to layout and check our design members. You come to layout here and you click on utilization ratio. You can see this is a member that I choose. These are the one that I designed. Yeah. Universal beam. Let's check. These ones, see this one tends to be high. That's why they use tappard, you know. At this junction, this first beam is higher. See, it's designed at 356. This second one too. Okay. As you are going, see that it's reducing. Here now is 254. Then it still increases. 305, 356. So you know that at the middle it reduces. Okay, 35 something 505. So if you're not using tappard, you use this bigger one, 356. Then for the coal, those are the universal. Then for the channels, the pro lines, I choose 150, but it designed at 125, which is okay. Through 5 in the 356 175 356 by 175. Yeah, that's okay. And check the ones that design. Then anything more bigger. My bracings came back at 100. I think my bracing will be angle of 100. Okay. But these ones will be 50-50, as you can see. So these are the things that you use in drafting your result in AutoCAD or whatever software you are using to do your drafting. So we'll proceed. We use our reactions. We use these reactions and design our footings in. We design our footings in proto structures. That is my own work process. So we are going to do that next.